number 7 again. So the question number 7 says that two cards are drawn from a well shuffled deck of 52 cards. Find the probability distribution for number of jacks. So we have already done this part, that the value of x will be either 0 or 1 or 2. Okay. Now we have 52 cards with us. Out of them, 4 are jack cards and remaining 48 are non-jack cards. Okay. First of all, we will find all possible outcomes. So we are selecting out of 52. So all possible outcome will be 52C2. This part is clear. So in denominator, we will get 52C2 in all the probabilities here. Okay. Is it clear?
Yes, sir.
But in numerator, the first thing is we must have zero. We must have zero jack. Means zero card must be selected out of these four, and two card must be selected out of these 48. So the favorable outcome will be 48C2. We can leave this 4C0 because this value is already 1. Okay. Whereas in the second part, it is one jack card. So one card must be selected out of 4. So numerator will be 4C1 into 48C1, one from each group. Okay. Now the third one is two jacks. So here the numerator will be 4C2. Any doubt from this?
So 0, 1, I got the answer. For 1, I'm not getting.
For 1, how we have to solve this? Okay. Here it is 4C1. So 4C1 we can directly write it as 4. 48C1 we can directly write it as 48. Okay. Whereas in denominator it will be 52 into 51 divided by 2 into 1. Is it correct?
Yes, sir.
Now further this 2 will be multiplied with numerator. So 2 into 40, 52 into 51. Okay. Now 4 ones are, it will be cancelled in 13 times. Okay. So it will be 2 into 48 divided by 13 into 51. Is it clear? Okay. So numerator will be 96. What about denominator? So 13 ones are 13. 3. 1 will be carried. 13 5s are 65 plus 1, 663 upon 96. Further, we can divide by 3 also. So 3 3s are 9, 3 2s are 6, 3 2s are 6, 3 2s are 6, 3 1s are 3. So 32 upon 221. I think this will be the answer. Okay, is it clear?
Yes, sir. So I've done the for the two cards also, the last part.
Okay, so we can move to the next question. Next, read question number 8. Question number 8. Just read this question. So 4 bad oranges are mixed accidentally with 16 good oranges. So 16 were good oranges and 4 were bad oranges. So both of them gets mixed. So in total we got 20 oranges. Okay. Is it clear? Now the
Yes.
question says that find the probability distribution of number of bad oranges if we have drawn 2 oranges from this. So how many oranges we are selecting from this? We are selecting 2 oranges from this. Okay, so all possible outcome means number of element in sample space will be 20C2. Okay, because we are selecting 2, and we have to determine the probability distribution for 2 oranges. Okay, so the value of x will be 0, 1 and 2. Okay, now the probability distribution, calculate the probability distribution in same way. Here the denominator will be 20C2. In all the cases denominator will be 20C2, whereas the numerator in the first part, numerator will be, what will be the numerator for 0 bad oranges?
So I think it will be 2C0.
Why 2C0? No, look, here it says that zero bad oranges are selected. So we can select the oranges from these two groups. Now the favorable outcome is two oranges are selected out of 16, whereas zero oranges selected from this. This is how we will get zero bad oranges, correct? So the combination will be 16C2, the numerator.
Yes, sir.
Okay. Now the next part, one bad orange is selected. So out of 16, we must have one orange, and out of 4, we must have one. Now two bad oranges selected, so it will be 4C2, correct?
Yes, sir.
Okay. Further, you can solve this expression and you will cross check your answer with this answer. Okay. So can we move to the next question?
Yes, sir.
Okay. Okay. So just read question number 10. Question number 10. So question number 10 says that a box contains 12 bulbs of which 3 are defective. Okay. So a box contains 12 bulbs. So total there are 12 bulbs, out of which 3 are defective, and the remaining 17 bulbs are non-defective. Clear? Further, a sample of 3 bulb is
So
selected
the
from.
three are already included, no?
Yes, 3 are already included because it says that it contains 12 bulbs of which 3 are defective. Oh, sorry, I have written something wrong here. Uh, a box contains 12 bulbs, no? So it is 12 bulbs. In total, it has 12 bulbs, out of which 3 are defective and remaining 9 are non-defective. So 3 are defective, 9 are non-defective. Is it correct? Okay.
Yes, sir.
Okay. Let X denote a sample of 3 bulb is selected. Let X denote the number of defective bulbs. So here X denotes the number of defective bulbs. Okay. So we are selecting 3 bulbs out of this 12. Okay. So how many defective bulbs we can have? Either we can have 0 defective, or we can have 1 defective, or we can have 2 defective, or we can have 3 defective. Clear? Now
Yes, sir.
first we will calculate n of s, that is all possible outcome. So number of element in sample space. So it will be 12C2, correct?
Yes,
वो
sir.
बैठे हैं क्या?
The three.
अच्छा कहीं गए हैं क्या? ओके. कौन है, अपने यहाँ के हैं क्या? बच्चे नहीं है ना? ओके ठीक है. Okay, yes. So all possible outcome is 12C2. Okay. Now, when we calculate the probability, first the denominator will be 12C3 in all the cases, 12C3, and this will also be 12C3. This will also be 12C3. Okay. Now, what about numerator? Zero defective. So all the bulbs are selected from this group. Okay. So
So,
it's
so it will be 9C3.
correct, 9C3. In the second case, it will be.
So one defective and two non-defective.
Okay, so the numerator will be
2C1 into
huh?
9C2.
uh, 3C1 into 9C2. Yes,
So then 3C2 into 9C1
correct,
and then 3C3.
correct. Okay, further you can solve and you can cross check your answer. Now let's move to the next part, question number 11. Okay, now try to solve question number 11 by your own. Okay.
Sir, done this one.
Okay. Okay, so I think we can start with the next exercise and next topic.
Yes, sir.
Okay, so for the next exercise, actually, next topic is based on, just write down the heading, mean, mean, and variance, variance of probability distribution, of probability distribution, distribution. Okay, so the mean is represented by either mu or x bar. Now the mean of any random variable is equals to pi into xi. Now what is this pi and xi? Here xi are the elements of random variable. In case of probability distribution, let us consider the random variable x has element x1, x2, x3 and so on, and whereas its corresponding probability p of x are p1, p2, p3 and so on. So here the mean of this probability distribution can be calculated by using this formula, summation of pixi. So first we have to make a table which will give us x1 p1, x2 p2, x3 p3 like this, and further we will add all these terms and we will get the mean of this random variable. Is it clear, Shavi?
Yes, sir.
Okay. Now the second is variance. So variance is represented by sigma square. Actually, the formula for variance is summation pi into xi minus mu whole square. So how we calculate by using this formula? If we have calculated this mu, okay, then what we will do, we will subtract each element of this random variable with mu. We will take the square of that and multiply with this corresponding probability. But some important conclusions are there. Using that we can easily calculate the variance. Some shortcut method or shortcut formula is also there, and that formula is sigma square is equals to summation summation pi into xi square minus mu square. Here mu is nothing but mean. Okay, so by using this formula also we can calculate the variance. This formula is better in case we have distribution table with us. Okay. Okay, one more thing, sigma is actually standard deviation. So in case we have calculated sigma square, that is variance, and further it is asked to determine the standard deviation, then we will take square root of that. Okay, now we can move to solve the exercise based on this exercise 9.2. Okay, so just check exercise 9.2 from this. Okay, exercise 9.2, question number 1. Question number 1 says that a boy throws a coin. He received 2 rupees for getting tail and 10 rupees for getting head. Find his expectation. That means mean receipt. Okay. So what are the possible values of x? He will get either rupees 2 or he will get either rupees 10. So the value of x will be 2 or 10. Now, what are the corresponding probabilities of each amount? So, probability of winning 2 rupees is 1 upon 2 because it is based on we are getting tail. So, probability of tail is 1 upon 2 and it is also 1. Now, we have to determine the mean value. So, first we will calculate x into probability of x means product of this. So, product of these two we will get 1 and product of these two we will get 5. Okay, now these are the px1 p1 or p1 x1, this is p2 x2. Now we will take sum of this, so mu is equals to 1 plus 5, that is equals to 6. So the mean amount he will receive is rupees 6. Okay, is it clear, Chevy? Now try to solve the second part.
So like I understood, but how we have to show this, the solution for this question?
Yes, Chevy, what's your doubt? How we have to show the
Yes, so like it is unfair, but like how should I show the solution?
which one? The second question.
Yes, sir.
A game of school has fair cost rupees 20 and prize rupees 50. If probability of winning is, just wait. एक मिनट कॉल कर रहा हूँ ना मैं. Okay, so a game at school fair cost rupees 10 with a prize rupees 50. If the probability of winning is rupees is 1 upon 10, is it a fair game? Okay, so the answer is whether it is a fair game or not. So if mu is actually, if means mu is same, what value of mu you are getting? Mean.
So like here 1/10 is the winning probability, no? So I have subtracted it from 1. So 9/10 will be for the losing.
Okay, but the value of mu you are getting is,
So mu I have not found.
okay, look, first what we have to do, x is equals to, now what are the values of x? uh, Look, the cost of game is rupees 10. If you win the game, then your total profit is rupees 40. Okay, if you win, then 40 rupees will be your gain, correct?
The 50, no?
No, 50, but you are paying rupees 10 for playing the game. Okay, so
Yes.
the effective profit will be rupees 40, correct? Now further, if you lose the game, then your effective loss will be minus 10, correct? Now the probability of winning the game, probability of x is what? The probability of winning the game is 1 upon 10 and probability of losing the game is 9 upon 10, correct? Now we will calculate pi into xi, so x into p of x. Okay, so this value will be 4 and this value will be minus 9, correct? So when we find the value of mu, it will be minus 5, correct? Okay, so on an average, you will lose rupees 5. So it is not a fair game. If this value will be 0, then it means there are equal chances. It will be a fair game of winning and losing. Okay. Now solve the next part, third part. Here you can directly solve this. You can directly use the table to find the value of mu. Now try to solve the third, fourth, and so on. Yes, Chevy. So, are you able to solve the third part? You're getting the answer.
Yes, sir. Third one done.
And fourth one?
So doing that.
Okay.
So done the fourth one.
Okay. You got the value of variance also?
Yes, sir.
Okay. Now, that fifth part, you can check the fifth part. You can solve the first part of question 5. Check this. Okay, so if you are able to solve the question 5 and 6, then you can leave this and right now and do it in your home as your homework. Okay.
Yes, sir, I've done fifth one.
Okay, so sixth is also same. Here
Yes,
in question number 6, this C is doesn't mean combination. It is normally like, okay.
yes, sir, understood.
Okay, so now the next question number 7. Just read question number 7 and check and tell me whether you are able to solve this or not.
So maybe once we can solve the seventh question.
Okay.
So we have to form the sample space also for three coins.
Yes, I think it will be better to calculate the probability. Okay. Should I solve this on board or you're trying this? Seventh.
So I'm solving it once. In my
Okay.
so like you, I think you told once, no, that in order to find sample space, there is a formula that like total number of, like for example, in terms of a coin, that how many combinations will be possible.
How many outcomes? Yes. So in one toss, we will get two outcomes. And if we are repeating it three times, so 2 raised to power 3 outcomes will be there. So it will be 8 possible outcomes.
So once can you please show the sample space?
Okay. Look, how to create sample space in such cases. Uh, Either you can use this tree method, first head, second tail in first case. Again, head and tail. Here also again head and tail. Okay. Now again head tail for both of these condition, head tail for these two condition, head tail for both of these two condition, head tail for both of these two condition. Okay. Now we will start with this first line. So H H H. So first outcome will be like triple H. Okay. Second H H T. So second will be H H T. Third H T H. So third H T H. Fourth H T T. So H T T. Fifth T H H. T H H. Fifth T H T. Sixth T T H. Seventh T T T. Like this. Sorry, eighth. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 possible outcome. Like this. Okay.
Yes, sir. So it's like this is limited till like how many times can we use this? For example, if it says that 10 coins are tossed, so like still we have to draw such tree and then write the sample space.
No, in that case, we cannot write the sample space because it will be a huge sample space. Huge points are there. like 2 raised to power 10 points are there. So for
Yes.
such cases, the questions are different. And in those questions, we don't need to write sample space. Basically, that questions are based on that binomial trials. And I will explain how that question can be solved. Okay.
So like here, was it necessary to draw this sample space, or we could have solved it without this?
No, in this case, it is not necessary to draw the sample space, but right now we have to calculate here the random variable x is defined as number of heads, na? Correct. So the value of x will be either 0, 1, 2, 3, like this. Okay. Now, when you are calculating the probability of each outcome, then if sample space is in front of you, then you will not make any mistake. So that's why it is good to draw the sample space. Okay. So for
Yes.
0 heads, now what is the probability of 0 heads? Means all tail. So it will be 1 upon 8 like this. Okay. Now similarly for 1 head, what will be the probability?
So 2/8.
No, it will be 3 by 8. 1 head. So check the 1 head cases. So this is 1 head.
Yes, sir.
Okay.
Got
This
it.
is 1 head. This is 1 head. So 3 cases are there. Now 2 head, again you will get 3 cases where you will get 2 head like this. These are the 3 cases. So this probability will also be 3 by 8. Now for 3 head, it will be 1 by 8. Correct?
Yes, sir.
Now further you can use the formula to calculate mean and variance. Okay, now further calculation you can do it. Now check the question number 8 first. Yes, how to solve question number 8?
So first we'll find the probability for two cards.
Yes, and that probability distribution will be exactly same to
Yes,
that question we have done in first question we have done in today's class. Correct?
yes, sir.
That question based on the 2 jacks, here the 2 kings are there. So same probability distribution will be there, and further we will calculate mean and variance. Okay.
Yes, sir.
Now check question number 9.
Sir, once can we solve question number 9?
Yes. Okay, just so read question number 9. Unmute the mic and read that question number 9. So what are the datas in question number 9?
So we have 5 red and 2 black balls.
5
That means total number
red.
of balls will be 7.
Yes.
And it is saying that 2 balls are randomly drawn without replacement. So we have to find the probability of black balls drawn
Okay.
when mean variance of the black balls itself.
Okay. So the situation is like this. So if we are drawing 2 balls out of this box, then the number of black balls will be either 0 or 1 or
It
2.
will be the same, no? 0, 1. Yeah.
Yes, correct. Now probability in each case. So probability of getting 0 balls. Okay. So we will get all the 2 balls from this group, that is from red group. So it will be 5C2
5C2.
divided by,
7C2.
correct. Next it will be 5C1, 2C1.
And 2C1. Yes, sir.
Yes.
7C2.
And last will be
2C2.
correct. Further, you will calculate the values, numerical values, and solve for
Yes.
mean and variance.
So 10th one is also similar. I'll be able to do this.
Okay. So next check for question number 11.
So this with replacement and without replacement will always be mentioned in the question, no?
Yes, it will be mentioned in question.
So like if we are, it says that a sample of 4 items is drawn at random.
Yes.
So that means like either it will have 0 defective items or
Yes.
1 defective and all are fine. So like in this way we'll have 0 to 4. 0,
No,
1.
we 0, 1, 2.
So why?
Because we are drawing four
Yes.
items
Hmm.
and we have only two
Two
defective.
defective items. Yes. Sir.
Okay.
So once can I solve this question?
Yes. Okay, so the question number 11 says that from a lot of 6 items containing two defective. So lot has 6 items in total. Out of them, two are defective, four are non-defective. Okay. 4 items are drawn at random. So we are taking 4 items from this. Okay. Now the question says that the random variable x denotes the number of defective items. So if number of defective items x can be either 0 or 1 or 2. Maximum we can have 2 defective, because in total we have only 2 defective items here. Okay. Now we will calculate probability of each case. So probability of getting 0 defective. So all 4 are selected from this group. Okay. And no one is selected from this group. Okay. In first case. So the first case numerator will be 2C0 4C4 divided by denominator will be 6C4. Is it clear? The first part.
Yeah, yes, sir.
Now the second, try to answer the second. Probability of one defective. Yes.
And- Sir, I think I'm confused here a little bit.
Okay. Now the first part is clear.
Yes, sir.
Zero defective, so zero bulb is selected from the out of these two, and four are selected from this. Now it says that one defective. So out of two defective, one is selected, and
Yeah.
remaining three, because in total we are selecting four. So remaining,
4C3.
yes, 4C3. Now, in this case, two defective bulbs are selected. So, out of two, both the two bulbs are selected,
Yeah,
but
so 2C2 and 4C2.
correct.
Yes, sir.
Okay, now further you can calculate mean and variance also. Na?
Yes, sir.
Now, check the question number 12. Okay, I will explain that 12th question. Okay,
So the table is required here.
in question number 12,
Yes, sir.
yes, it is required. We have to make the that probability distribution table first. Okay, so the question says that two positive numbers are selected at random from first five positive integers. So what are the first five positive integers? They are 1, 2, 3, 4, 5. These are the first five positive integers. Okay. And we are selecting two numbers out of these five. Okay. Now The random variable x denotes the larger of two number. Here, the random variable x denotes larger of two numbers. Okay. Now, what are the possible values of x? Try to answer this. Not having any idea? Okay. Look, suppose if we select 1 and 2, now which one is larger among these two?
So 2.
2. So it can be 2. If we are selecting 1 and 3, which one is larger? It is
3.
3. If we are selecting 1 and 4, then which one is larger? 4. If we are selecting 1 and 5, then which one is larger? 5. Correct?
5.
If any other combination we are selecting, suppose we are selecting 4 and 5, the value of x will be 5. But the
So
value of x will
so-
not be x. The value of x will not never be 1.
yes, sir. So but like it says larger of two numbers.
Yes.
So that means the addition or like individually the numbers should be more than 2.
No, if we are selecting any two number, whichever, which any one number out of these two is larger, we will take that as x.
So then why are we considering 2 here? Like it says larger of two numbers.
Suppose we have selected 1 and 2, these two numbers, then which one is larger among these two? It is 2. So that's why we have selected 2. Okay. What are the
Yes,
possibilities of selecting two numbers? Either we can select 1, 2, 2, 3, 1, 3. Different possible outcomes are there. Correct?
yes, sir.
Okay. So is this part is clear to you?
Yes, sir.
Now the probability in each case. Now understand this carefully. Okay. Now what are the probability of getting 2 as our outcome? Okay. First of all, we will calculate n of s. That is all possible outcomes. Okay. Now what are the all possible outcomes? Try to answer this. How many numbers we have with us?
So we have 5.
And how many we are selecting? We are selecting 2.
4.
We are selecting 2, na?
Yeah.
Out of 5,
Yes.
we are selecting 2 numbers, na? Correct. So what
Yes.
are the possible outcome? It will be 5C2. Is it clear? So
Yes, sir.
in denominator, we will have 5C2 in all the cases. 5C2 and 5C2. Correct?
Yes, sir.
Now, for 2, for getting 2 as the larger one. Now, what are the possibility of getting 2 as larger one? So we have to. I think it is better to calculate manually. When we will get 2 as larger one, either we will get 1 or 2. If we are selecting 1 and 2, this combination, then only we will get 2 as larger number. Okay. So if our selection is 1 and 2, only in this case we will get 2 as larger number. Correct? So it has only one possible outcome, one favorable outcome in this case. Now, when we will get 3 as larger number, in two different situation we will get 3 as larger number. First is when we are selecting 1 and 3, and second we are selecting 2 and 3. Correct?
Yes, sir.
So it has two favorable outcomes. Clear? Now, what are the possible situation when we will get 4 as larger number? When we will
So
get 4-1, 4-2, and 4-3. So there are three possible outcomes. So it will be 3. Now what about this?
4.
4. So it is 4. Clear? Now we can cross check whether we are making a correct distribution table or not. For that, what we will do, we will calculate the value of 5C2. Okay. So 5C2 is 5 into 4 divided by 2 into 1. Correct? Okay. So 2 ones
Yes.
are 2 twos are, so it is 10. Okay. Now the denominator is 10. So 1 upon 10, 2 upon 10, 3 upon 10, 4 upon 10. Correct? Now add each of the probability or add all the probability. If we will get 1, then yes, our distribution table is correct. Okay.
Yes, sir. This one.
Okay. So this will be the probability distribution. Now further we have to calculate the mean. So just multiply each of the probability and its element and take a sum of this, and you will get the mean. So 2 upon 10 plus 6 upon 10 plus 12 upon, it is 10. 12 upon 10 plus 20 upon 10. Okay. So you will get 4 as mean, and further you can solve for variance also. Okay.
Yes, sir.
Okay. So till this exercise, all the points are clear, Chevy?
Yes, sir.
Okay. So further in next class, we will do that binomial expansion.
Sir, I have
Binomial
one
expansion.
doubt from determinants.
Yes. Tell me the page number.